And we are live. Thank you, everybody. This is workshop number 2, Applied ZK for our. I always mess up the name. It is the Quill and Scribes competition, which it literally, like on the weekend, it just hit my head. Scroll is an actual scroll, right? So you're actually writing stuff down for a writer's competition. Genius. It just went over my head. I was going Benjamin Franklin on here with a feathered pen. But, anyways, bad jokes aside, this is for the ongoing Quill and Scribes competition. Submissions are due this Thursday at midnight UTC. This is the second workshop that we're going to be doing Applied ZK with Ahmed. I'm just going to go ahead and pass it over and just get right into it. Go for it, Ahmed.
Yeah, thanks. Yeah, thanks for having me. I think give Scroll this space to talk about this topic. I think it's super interesting, something that I really like. And yeah, let's just get started with Applied CK and how you as a developer can do privacy apps on, and why do you want to do it on a layer 2. So yeah, so let's start from the basics, like what is a CK tab, and maybe if you're familiar with Solidity and you have already created a tab, smart contract app that has a smart contract and also has a front end, and a CK tab will be something that will look like this. That you can use your Solidity smart contracts in the same way that you usually do. You can sign transaction with MetaMask and do like DeFi transactions or identity or NFTs or whatever. But with the new thing that now is possible thanks to CK, that you can have private parameters on your tab, which sounds like something like very crazy and new, and maybe you may be asking like how is that possible to have private parameters in a public by default environment, which is like Ethereum. But yeah, that's what we're going to unpack here. Like just a bit of a spoiler, it's not as easy like as I'm putting here, like in the specific function. But this is a good place to start and to get an idea. And yeah, that's basically what we will be doing. Also, you may have heard before about this word like circuit. Like we're going to be doing circuits in this workshop, and the way that I want you to think about circuit, which are fundamental to creating a CK tab, is the following way. So we as a developer, we are used to write functions like I'm expressing right here on the left. So we are used to send parameters to a function, make some execution, and then receive an output. That's what our mental model of creating a tab is. But on a circuit, what you're going to do is, it looks quite similar because we have loops, we have parameters, we have if statements, we have functions, but the actual logic behind this is a bit different. So I want to think about it the following way. We're going to pass the parameters, the same as in a function, but we're also going to pass the result of the execution. So we pass, as parameters, we have passed the parameters and the result too. And then we pass it to a circuit, and the circuit will produce a proof. And then with that proof, you can execute something like elsewhere, which is going to be in a smart contract, as you will see in a minute. So yeah, this is a very new concept. At least for me, it was very hard to grasp this because it took a little bit of time to change the mindset. But yeah, hopefully by the end of this workshop, you will have a better view about it. And also, go ahead.
Question about that. Yeah, sorry about that. Sorry to cut you off. One question. So the function, we're putting in 2 parameters and we don't know the output. The function is giving us the output. We don't know what it is. But when we're doing a circuit, we're putting in the parameters and we know the outcome, but we're using all that information to create a brand new circuit, basically for our proof, in a sense.
Exactly.
Got what we're trying to do. Okay. Interesting. Okay.
Yeah.
again, I know
Yeah,
this is a difficult subject, so anybody out there that has questions, go ahead and throw your questions. We'll pop them up on the stage, have Ahmed answer them to the best we can in our workshop. Yeah.
yeah. Feel free to interrupt me, and yeah, if you have any question, anyone in the audience has any question, yeah, go ahead. Yeah, because as you said, this is not easy, and it's good to yeah. There are no silly questions, especially in CK today, that there is not a lot of information out there. So yeah, happy to help on that. Okay, so what we're going to do right now is create like our first CK app. So we're going to create a circuit. We're going to see how a language to create circuit looks like. Then we're going to create a verified smart contract. So all your Solidity skills that you already have also apply when you create a circuit app. So it's not like the circuits are replacing the smart contracts; they are working together. So that's what we're going to do here. And also, we are going to learn a couple of techniques. One is the nullifier, but we're going to learn a couple of techniques that help preventing stuff like double spending or keeping anonymity in a public environment. It's not trivial. So we're going to learn a couple of techniques and or tactics to go ahead. Yeah, do you want to say something?
Oh no, I was just following along
No.
on there.
Okay, sorry. Okay, so um, let's yeah, just go ahead before going into like we'll do like a typical architecture, like so you can put all the pieces together. But first, let's start with a simple hello world so we can get more familiarized with it. So I have here uh, a blog post that I'm sharing with you here. Also, Billy, if you can help me putting it in the link on the chat if you want to access it from the chat. You can scan this and go to this article that yeah, so we're going to create a first like simple circuit so we can get the idea on how we're going to put the pieces together. So first, in this example, we're going to use Noir to write the circuits. And Noir is not the only language to write circuit that exists. There are a couple of other ones you may have heard about Circom or Socrates, but we're going to use Noir. Noir has a good documentation, and it's very new, so expect breaking changes. But even with that, I think it's a good language to get started. So here you have the installation instruction on Linux. Just copy and paste this, and also MacOS on both Apple and Apple Silicon and Intel. And once you have it installed, it should look something like this. Basically that's going to install the nargo command, and the narg I'm using the version 0.22.0, and yeah, that's the version that we're going to use now. And yeah, let's just get started by creating a circuit and generating a proof. It's going to be a very simple one, just so you get a good idea. This will create a new project. We're going to go into that project, and we're going to do an argo check just to like is to basically check if it's not compiled, but yeah, it's kind of compiled. You will go like compile the circuit. We're basically going to check if the circuit is reading in a good format. So let's see how the circuit looks like. And also forgive me that I'm not and the Noir files are not yet supported by default on because this is something very new. So
Right.
forgive me for not having the linter on. Yeah.
Got it. So,
Uh,
real
yeah.
quick
Go ahead.
question. So, so we're basically building the circuit. Now, do we have to work on the framework that we're using now, or for someone that's like specific with Solidity, can they use Hard Hat? Can they use, a Foundry for theirs, or can they
Oh,
separate it?
yeah.
Yeah.
Yeah, it's separated, but you
Okay.
will need to use a framework later on. So you can
Got it.
combine this with Hard Hat, with Foundry. We're going to combine this right now with Remix. But
Got
yeah,
it.
it's going to be separate. It's going to be separate. You don't do this from within Hard Hat. You just have maybe in your GitHub repository, you may have like um, two folders, one for your hard hat stuff and one for your Noir stuff. Yeah, it's going to be
Got it.
separated.
Got it. Like how you would mix your front end and your back end, right? Two like folders that could have different frameworks.
Yeah, exactly
Yeah.
like that. Yeah.
Got it.
Here, as you can see, I have some testing going on here. We're just not going to care about that at the moment. We're just going to focus on the circuit. And this is the circuit. And as you can see, it has a lot of similarities with a normal programming language. And by the way, for all the Rust lovers out there, they base their syntax on Rust. It's not Rust, but it's a very heavy inspired. It's very heavy inspiring on Rust. So as you can see, we have a main function that receives some parameters, and then we make an assertion. So assertions or checks or requirements, whatever you want to call them, are very important on CK. So this circuit, it receives X and Y as parameter, and he basically checks that X is different than Y. And only if X is different than Y is going to be correct. So that's our assertion. And only if the assertion is correct, you're going to produce a proof, which is the output of the circuit. Then we're going to use the proof later on, but we can worry about the proof later. So here, basically, it's about the just proving that X and Y are different. But there's one very, very, very important thing, is that we have Y as a public parameter and X as a private parameter. If you put pub here, and this is going to be very similar in whatever other circuit language that you use. If you use, for example, Socrates, it's going to be very similar. If you use Circom, if you use Halo 2, it's going to be very similar. And here on Noir, we have like public and private inputs. And everything is private by default. So if you want to make something public, you have to specify. So here, X, private, Y, public. So the thing is that, we can just check it out. We're just going to save here. And you can, if you want to check it out, you can go to here, prover. And when you did nargo check, this file was generated for you, where you can pass the two parameters. So you can put, for example, here 1, here 2, and then you will be able to produce a proof. Just put on your console nargo proof. It's going to take a little bit. Yeah, that was it. The proof was generated. And here you can take a look at the proof, which is a big number. This is the proof. And this proof is going to be sent as parameter to Solidity later on. So we're going to go there in a minute. Let's see what happens if we put the same number. In this case, we won't be able to generate a proof. So let's try that and say, yeah, constraint failed. All the constraints were not satisfied, so we were not able to produce a proof. So this is the circuit part. And just so you know, this is a very naive and very simple, it's like hello world type example. But what if you can pass as a parameter as a token transfer on DeFi, for example, if you can pass a user or an Ethereum account as a parameter. And by the end of this workshop, we're also going to see how a circuit that you pass an Ethereum address as parameter looks like. And or what if the amount that you are sending is private? And this is stuff that you can do here. Of course, it's not trivial. There are also a lot of caveats that I'm going to also be talking about it in a moment. But yeah, what I want us to do now is just to continue here and verify the proof. So the thing is that this proof can be verified by anyone. You can pass this big number, and when you pass it to someone, he will be able to know that you passed two numbers parameter, but he won't be able to know one. But we want the cool thing about CK is that we can pass this proof to a smart contract, and the smart contract can verify for us if the proof is valid. So how is it going to look like? You have a smart contract, you have a verify function that's going to return true or false. Yeah, and the extra cool thing, something that I really like about this language, is that the smart contract is going to be generated automatically for you. So as you can see, you may be able to recognize what is this. And as you can see, it's a Solidity file. It has a lot of numbers that we don't need to understand it. It's just like boilerplate stuff with some math stuff that I personally don't understand what's happening. But it's generated for us, so we don't have to do it. And also this code, this all like the DSL, if you use whatever other language, is also going to be the same. So what we're going to do next is just launch this smart contract, and we are going. You can launch it like on almost any EVM chain. We're also going to talk about it in a moment. But yeah, we're just going to use scroll, of course, because that's what this workshop is about. And yeah, so I think my just going to refresh because usually remix gets stuck in there. Yeah.
Question, I don't know if you've ever done it before, but can you do it on the local Java virtual machine, or do you have to deploy it to a chain?
You don't have to deploy it. You can do it like in the local machine. Yeah.
Got it. Okay.
And yeah, actually, I think it's super cool that you can just try smart contract stuff without just deploying a contract.
Yeah.
Okay, so we're going to have two contracts actually. One is going to be the verifier, which is this one. So let's start by deploying this one. Okay. Oh, this is very important. So you may get this error on Noir. So you have to go to advanced configuration and you have to enable optimization. Yeah, this is something that may be a little bit tricky. So yeah, now you should be able to compile. Well, you have a warning here, but yeah, don't worry about this warning. So we can deploy now. Yeah, as we mentioned, you can also deploy using the JavaScript, but yeah, we're just going to deploy here on scroll.
And all this is in the guide, right, that we put on the QR code?
Yes, this is all in the guide.
For those that are trying to follow along, that's the file that I posted up just previously, just in case.
Yeah, thank you. Okay, so we're going to launch this smart contract that basically we're going to have two smart contracts. One that's auto generator, that's for that's the verifier contract, and here I'm going to call them like custom logic. So we can do all the Solidity stuff that we are used to do. And as you can see on the constructor, we're going to pass the verifier, which is the contract that we just deployed now. So we pass the verifier, we store it, and this contract has this function here, has this function, the verify function, that receives the proof as parameter. And this function is here. This function receives the proof as parameter and returns true if the proof is correct. So this is you as a CK app developer, what you would usually do is that you will have this proof, like any execution that you want, where you want privacy on, is that you are going to receive a proof as parameter, and the first thing that you're going to do is just verify if the proof is correct. And if it's not correct, here specifically in Noir, the way it works is that if the proof is not correct, it will just revert. So if it didn't revert, the proof was valid, so you can continue with whatever logic that you want to add. So in this case, the logic that we're going to add is just store in the state your public input. So as you remember, we have a private input, X. X is private, right? X is private because everything is private by default, and Y is public. So our custom logic is going to be very simple. We're just going to store Y. So let's try out.
Right before we get into that really quick, Clip was asking if we can repeat the part where we assign the variable to make the proof. So right before you did the proof generation, I don't know if you want to finish the flow and then maybe recap it, or if you want to take it however you want to go on that. It doesn't have to be right now, but whatever makes the flow better.
Yeah, I'm going to just deploy this contract, and also I'm going to generate. I will need to generate a new proof because um, this the last one that we did, we made it fail on purpose. So yeah, we're going to
Oh,
launch
okay.
another one.
So we'll have to redo it again anyway. Okay.
Yeah, cool. So yeah, so in the constructor we send the verifier address. So the contract that gets automatically generated, you just deploy it as is. You just don't make any changes. You just don't touch it. You don't need to work with it. And here we're going to pass it as a parameter, yeah, just to store it, so we can verify our next next proof. So here, so this is the verifier contract that was automatically generated that has this verify function, and that function is going to be called from our custom logic contract. So the custom logic contract is going to store here, which now is 0. We're going to store y in here. And the parameters are the proof and the public inputs. The proof is the big number, and the public inputs is y, because in this case it's just y, because y is the only public parameter. If you have many public params, you can pass them here. So yeah, let's generate the proof. So at the beginning, when you just create your project, you don't have a proof. I'm going to delete this. You don't have the prover and the verifier file. They get generated for you. So I'm just going to delete them.
Quick
So
question on that one statement. Sorry to cut you off. Do you
yeah,
mean it's only the public input that needs when you want to verify? So you need the proof and the public, right? In a sense. Got it.
yes. That's the two. That is usually like that in any smart contract language. We usually call them DSLs, like Noir. This language we call it DSL because it's a domain specific language, which means, sorry, it's a language that only serves one purpose. So yeah, domain specific language. So in any CKDSLs, we pass always two things. One is the proof, and the second is the public inputs. And we have to pass the public inputs because it's with the public inputs that you can do custom logic. Without the public inputs, we wouldn't be able to do custom logic. So, for example, if you are passing, like as your, for example, for a voting application, you can anonymize your user, but the vote is public because yeah, you need the vote to be public. So what he voted on to be public, so anyone can, so you can count it on your smart contract and trigger any logic, but you can keep your user private. So that's the cool thing. So the thing is that you always need public parameters so you can do your custom logic. So yeah, that's what we're going to do here. And
Would a bad
sorry, yeah.
example of this, and I'm pretty sure it's really basic bad, but it's like, okay, x plus y equals z, and I give you the value of x, and I give you the value of z in some kind of proof. Therefore, in order to like figure out what's what, to see what y is and prove that it's correct, you would need that kind of formula. Like, if I only give you one variable instead of two variables, it's impossible to find out because there'd be so many combinations of it to exist.
Oh no, but the thing is that you can have the three private variables. You can have that. For example, you can have like x times y equals z, and you can pass x, y, and z, and the three parameters can be private. But of course, you won't be able to have you won't be able to do any kind of custom logic with that because you don't have nothing to work on with. Yeah.
Right.
Yeah, and okay, so first we do nargo check. So it will generate the prover dot toml that is going to, so this is where you will be able to send params and generate a proof from here. Also, by the way, this is just for doing this on the console. Where you usually want to do this is on your front end. So you will have some sort of function that will call on React or Angular, Vite, or whatever you're using. you will have some functions that you will be able to send params to generate the proof on the browser. That's usually where you want to generate the browser, because you don't want to generate this in a backend server where you will expose your data, especially if you're doing private stuff. So you will usually need to do this in your browser. So yeah, here it's just like just using Nargo by itself to generate a proof. So here we just pass any params. For example, we're going to pass 3 and 7. Okay, they're different, so the only constraint is going to be satisfied and we'll be able to produce the proof. So now we make Nargo proof. We make Nargo proof, and thank you. We make Nargo proof, and that's going to generate the proof here. Here, as you can see, it generated the proof. It's a huge number. And also, we are going to be able to see the verifier.toml. And the verifier.toml has the public inputs. So you can grab the proof from here and the public inputs from the verifier.toml. Maybe I think they should have named this public inputs.toml, but yeah, they call them verifier.toml. Yeah. So let's try this. So I'm going to copy this big proof, and oops, sorry. And I'm going to put it here. Just a little trick: if you're using Remix, you have to put 0x at the beginning. Yeah, sometimes where you're doing this CK stuff is sometimes a bit hard to just convert one thing to another. But yeah, it's just a bit tricky. Just like a side note. So we paste this big proof here, and now let's put the input here, the public input, which is y, which is 7. And we put it in an array like this. And let's hit transact. MetaMask pops up as normal. And you confirm the transaction. And then here is our y stored now. So yeah, that's the basic and normal flow of your application. You have a circuit, you produce a proof, you pass the proof to Solidity, and then you can execute custom logic with that. And now the next thing that I want to do is introduce a new concept, which is very, very, very useful, which are nullifiers. And this is like the anti-double spend system. Because what if, imagine if what we're doing here is a private token transfer, or a private NFT transfer, or a private NFT mint, I don't know, whatever. And what if you pass the proof and it gets accepted by your contract, gets confirmed your transaction, and what if you pass the same transaction again, and you can use it like endlessly? So you don't want that. Like you want to put a stop on that, and just create a restriction on that. If you did something once, you can do it twice. And in this example, we're going to add some extra code in here. So let's copy this, and we're going to put it here on our circuit file. And this has some new code here that I think is very interesting. So first is that Noir has some library systems that you can import libraries. Also, you can create your own libraries and share them like in an open source way, which I think is very cool. Then here we have the same X and Y parameters. And here we have a public return value. So we're now returning a value here. The arrow means that we're returning something. So what are we going to do? Let's start by doing the same thing that we did before. Just check if the two numbers are different. But now we are going to hash. We're going to hash X and Y. We're going to hash them together. And why do we hash them? Because hashing is deterministic. And also hashing helps us with privacy. Those are the two properties of hashing. So for those who are not familiar with hashing, basically what it means is that from a value A, if you hash it, you get value B. And from B, the cool thing about hashing is that from B, you can't figure out A. But every time you hash A, you will get B. So it's deterministic. But it keeps, if you only know B, you can't know A. So in this case, we're going to hash it and return the hash to the smart contract. And why do we want to return the smart contract? Because we're going to we're going to make also some changes on the smart contract. We're going to nullify them. We're going to nullify that hash. And what does nullify means? That is a very new concept. If you're just used to Solidity, this may be a very new concept. But in general, what it means is that if you already nullify something, you can't do it again. So if you already transfer your token, you can do that again, but protecting your private inputs. So yeah, and so here, as you can see, we also pass the proof. We also pass the public input the same way, but now there are two public inputs, and that's why back to the presentation to remember that on the function we pass as inputs the parameters and also the return values. Now we are passing as parameter, but in reality is a return value, the hashing of x and y, and we're going to store it on the nullifier. So these systems allow us to just not being able to submit the same numbers twice. You can submit a new number and make a proof to a new number, but if you pass the same two numbers, you can do it twice. And yeah, this is extremely useful for voting applications, for, of course, all DeFi transactions, so you don't double spend. And yeah, this is like a very useful primitive on CK. So if you're writing CK application, you have to understand this concept. To be honest, it was hard for me to understand at the beginning, and you have to think about things differently, and has a lot of a lot of yeah, it has a different dynamic. But yeah, I think it's also very, very interesting, all the stuff that you can do with this. So
We
yeah,
have a quick question right now. So does Noir support other hashing besides Purgerson? Purgerson, did I say
oh
that right? Yeah.
yeah, Pedersen. Yeah, that's a
Yeah.
really, really good question. So as you know, hashing is something that some hashing functions are harder to prove in CK, and some are easier. And yeah, Noir supports, to answer the question, Noir supports Pedersen, Poseidon, which are really good functions for CK, but also supports Ketchak 256 and Blake, which are not very like CK friendly. And why do you want to use like the CK unfriendly ones? Is that it's because, unfortunately, a lot of things that Ethereum does are done with Ketchak 256, which is very, very, very CK unfriendly. So if you have a circuit that you make a proof, you will, if you can, you should use Pedersen or Poseidon, which are good functions for CK. They can make proof faster, so your user won't spend too much time just waiting for the proof to come up. But if you're doing some Ethereum specific thing, you may want to use Ketchak. So avoid it if you can, the Ketchak, but on Ethereum it's hard to avoid Ketchak. So if you're writing a CK app with good user experience, you may find yourself just using Ketchak. And yeah, there's sometimes no way around it. But yeah, that's a really, really good question. Yeah.
Another question came up. Do you need to have nullify in a different file from your custom logic? I see like when you pasted it in, it was all in the same file, but do you need to have it in a different file?
The very the what do you mean a different file? Oh, this verified.toml, this one.
No, I think under your source, the main NR.
Okay.
Keep going. Yeah,
Yeah.
right there. And so I see that you have your nullifier in this hash. So you're using the assert, and in the same thing, you're using the hash, and then you're
Oh
returning the
yeah.
hash, right? Yeah.
Yeah. This mean like return. It's just the syntax is different. Yeah.
Yeah. So I guess the question would be just
Mhm.
to have a nullify in a different file for the custom logic, because you can add your custom logic to the same file too, right? As well.
Oh, here you can't add the custom logic because the custom logic is what calls, well, actually is what I call custom logic. Is like you custom logic on chain. So you can add some, yeah, whatever you want on chain. So whatever happens here on the circuit is off chain, and this is not going to be recorded by blockchain. This is where you want to prove something, and if you want to do anything, so if you want to nullify on chain because here there are, so you can have trust as assumption here. So on your smart contract, you can be sure that that's going to be verified, and you're going to know for sure that's just only going to happen once. So on the circuit, you have to do the nullifier generation, and on your smart contract, you will have to do your nullification and store it on chain, just to prevent from someone to do it again. So yeah, you have to separate it. It has to be separated. Yeah. Okay, so now let's try this out. Let's try launching. Then you have to relaunch the new contract with the nullifier, and we're also going to make a proof, submit it, and submit it with the same numbers, even if the proof is different, because for the same numbers, you can have different proof, different numbers. That's why we need the nullifier. And we're going to submit it twice, and the second time has to fail. So yeah, let's try this out. So the first thing is that we're going to regenerate the solidity verifier. If you remember, it was this cold chain verifier. So it's going to generate it here. There you go. Yes, this one. So let's try this out. It's going to remove this, replace it with a new verifier. Also, I'm going to clean this up. Just launch it now. And remember, the auto-generated Solidity file, the idea is that you launch it as a standalone contract, and you just launch it as a separate contract.
Question on that one. Is there any particular reason why you have to launch it as a separate versus having it imported and then just using the libraries versus interfacing?
Yeah. You can actually use it directly, but there's one thing that you can't do. So the thing is that something that you can't do is just, for example, add something here. That's something that you can do because the smart contract is auto-generated to look for the proof in the cold data in a specific location. Mm-hmm. So this is something you can do. So you can't modify. You can add some code in here, but as you can see, this is a view function. It's a view function, so you won't be able to change the state. But you can modify here, maybe add a new function that it's public, that could be done. But the thing is that what if the same verifier contract receives, once the same verifier contract can be called from different like custom logic contracts and using the same code. So yeah, that's one thing. But yeah, it's actually not mandatory. It's not mandatory. You can modify here, but also your code look a little bit harder to use. But yeah, it's doable. Yes, it's not a requirement, just a recommendation.
Got it.
Okay, so yeah, so I already launched it. So now I am going to add the new custom logic, which is this one. And yeah, I think I already copied here. Yeah, this is the logic with the nullifier. So I compile, and the same as before, we copy the verifier address, pass it as a parameter, we deploy, and now we were going to go back to the verifier toml. Also, now it's here. Now we're going to be able to pass the proof and check if the nullifier is working correctly. And just as a recommendation, I think it's going to work well here, but just going to play it safe and delete the prover and the verifier, the toml files, just to check if everything is going to be generated regenerated well again if everything is working correctly. So we do nargo check, and then we can go here and pass two numbers, for example, 3 and 4. We save, we do nargo proof, and yeah, that's going to generate the proof and the verifier public inputs. So this is the proof, and this is the public input. So now, as you can see, there are two public inputs. We have the Y and the return, and this is yeah, it's challenging just to wrap our head around that the return value is actually the input on the Solidity contract. But yeah, that's the way it works. So here is our public input that we'll use for custom logic, and this is the return value. That this is the hash from X and Y that we're going to use to nullify. This is the return value is the one that we're going to nullify. And remember that this is deterministic, because one important thing is that, let's check here, for example. Let's go to the beginning of the proof. And if you go to the beginning of the proof, this proof starts with 2678. So now, if we pass the same parameters, the same everything, it's going to produce a different number. Both are valid. So you can't use your proof as a nullifier, because many proofs can be done to the same inputs. So you don't want that. So that's why we hash it, because the proof, yeah, you can have many proofs to the same computation, which doesn't help for a nullifier. That's why we hash it. So yeah, this is a bad nullifier. The proof is a bad nullifier. Don't do that. Instead, just hash it, return it, and nullify that. Yeah, so let's try it out. Let's see if it works. So we copy the proof, we pass it here. Now, other thing that is a bit tricky here, just take into consideration that here, for this is in alphabetic order, but the way that you have to pass it is actually the way that you declare it here. So first was Y, and then the return. So yeah, it's going to be the other way around, like this. Yeah, just be mindful of that. Okay, so this is going to be the public input in the position 0, and this is the position 1. Okay, this is position 0. Let's pass it here, comma. Now let's pass this one. Okay, here you go, and let's close it. So let's check it out. Okay, it works. So we're going to store 4, I think we passed, right? Or which one? 4, yeah. We're going to store 4 in our contract. Yeah, here it is, 4. But if we want to do it again, it won't allow us, because the proof was nullified. You can do that again. So yeah, this is a very important tool under your CK DApp developer toolbelt. Yeah, and yeah, this is very, very useful. And yeah, at this point, I just want to. We're not going to go through the whole process, but I just want to show you how like a more advanced CK DApp looks like. We're going to use anonymity set. We're actually going to anonymize our MetaMask account. Yeah, I think that's very interesting. We're also going to have a relayer. This may sound like a very fancy word, but the thing is that it's a very simple concept that's also very important in CK. Imagine that you are anonymizing your account, but you send a transaction on chain. Everyone will be able to see that it was you, because you will be able to look that on Etherscan or whatever. So your whole anonymity makes no sense. So what you do is that you just you create a proof on your browser, you sign it, and you pass it to a trusted relayer, and the relayer just grabs your transaction and they submit it on chain. So I created a small Node.js relayer that is just listening to a port, waiting for transactions, and submitting them on chain. And also something that's very important is that you have to do the proving in your browser. And the browser, of course, is more slow than generating a proof in a data center on a server, but you can't send your private data to a server because you will lose your anonymity. So you want to do it on your browser. So yeah, let's just take a look at this. I already have it prepared. And again, if you have any questions on the specific on yeah
on anything really, like
yeah
I know we have a dedicated for the scribe or quills and scribes competition, we have a dedicated Telegram chat. I'm going to go ahead and post the Notion with all the information on there for those that haven't signed up yet. You can still sign up. They're pretty much sign up until deadline on there, but it has the Telegram group, the previous video, it'll have this video too, with all the questions that people have. I think Telegram, you can look in the past as well if you want to see the previous conversations. And so in that case, the relayer handle private keys. I don't think so, right? Because you're setting up a signature, and what the relayer is doing is sending that signature as the message sender, right? Like it's just paying that transaction for you in a sense, but it just has that
exactly
message data. Yeah.
yeah. And you have to look for ways on how to incentivize the relayer, right? Because by
Mhm.
default it's not incentivized. You have to look for ways. And I think there is, even outside of CK, there is a lot of thinking about it. You have cow swap, and now also Uniswap before is joining like this intent-based systems. Also have relayers, and they have to look for ways of incentivizing them. I think it's a very interesting topic there. Just the relayers. Yeah,
Yeah.
and it's not only CK related.
We're
Okay,
getting to
so
a kind of abstraction, right? Like it's basically they're basically relayers for you. So they're taking the hit so you can use your DApp, right? Some
yeah,
people may do
exactly.
that.
Yeah,
You know, hey,
yeah.
we're private, so we'll keep your information private. Now you're going to use that DApp because you don't want people following you online, right? Like everybody throws out their ENS on their socials, but basically you're
Mm,
telling everybody, hey, you can follow all the transactions I've ever done on this wallet at any time. And now you
mm,
want to privatize because you have some kind of like online stalker or something, you know? And so now you want to go silent. You want to, be quiet about it. You don't want them to see the purchases that you're making or whoever. And
mm.
so now you have options to switch over to keep your transactions hidden. So kind of cool.
Yeah. Let's just try this demo and how like the user experience and user flow will look like. So this is like a just anonymous message board that you from your account you can post message here, but this is using an anonymity set. So you have a group of people that can post here, but only, for example, you can make something like only if you're an NFT holder, if you prove to me that you're an NFT holder, you can post a message here. But when you post something, no one will be able to know which of them you are. This demo. This is very basic demo, but shows the complete process on how like a MetaMask combined with Noir, combined with everything we work with the relayer works. So yeah, let's try it out. And let's put, I already have a message here set, which is grabbing it from the smart contract with custom logic. You can start to imagine how this is stored, maybe in a mapping or something like that. So we're going to do that now. So let's put this new message. We click send. So what happens here? So the different thing now is that we're not going to confirm and put the transaction directly on chain. We're just going to sign it. And here you can look, we can see what we're signing, and we just sign it. So we sign the transaction. Now, what's happening here is what we're generating the proof on the browser, not on the what's the name, like a prover.toml file. We're not generated the passing the inputs there, but instead in a JavaScript library on my browser. And it's going to take a long time actually. Yeah, it's going to take about a minute or two because and this is tied back to the previous question that we had, because we're using Ketchak, because your Ethereum address and your signature methods are using these methods called Easy Recover and Ketchak, and these are very, very long to prove. I think it's going to take about a minute for me, and yeah, that's a new explorer. But the good news is that this is improving like very fast, and there are a lot of papers yet to be implemented on Noir and other language that yeah just helps a lot. And also and I remember like back in the day, there was like even because I've been waiting so much for this to happen, because I remember like when we first started hearing about CK, there was even like people saw this like as a theory that maybe it's possible, maybe it's not. So at this point, I think it can feel like a really bad UX, and probably it is. But yeah, I think it's amazing to see that it's even possible, and I will get my hopes up because that's going to be improved, because yeah, there is so much research and so much people just thinking about it. But yeah, as you can see, it's a bit different. Just proving Pedersen than proving Ketchak,
Yeah.
it's huge difference.
Well, while we're waiting on the proof, I mean, I'm assuming you're going to be judging the zero knowledge portion of the blog post. What are you
Yeah.
looking to see? Like, what topics are you really like? I can tell right off the top that if you're not writing somewhere in your blog post, that if you're not writing it in the front end, that's an automatic disqualification, right? Right off the top. So, like, what are you looking for in the blog post? Like, examples of voting or like concepts. What would be like some of the tips that you would say that people like listening trying to do something on zero knowledge?
Yeah, I think that anything that you feel like it's worth, like an idea that, or anything that you feel it would benefit other developers, because this is something new, and this there is not a lot of documentation or ideas or demos. So yeah, anything. I think there is a lot of room to doing stuff here. Yeah, I think there's a lot of room. So yeah, we will be looking for something that's creative and that helps other developers. And by helping all developers, it could be like, okay, just making a tutorial, or also maybe giving your opinion on the different ways that stuff can be done. And yeah, just anything that helps other developers. And yeah, my advice would be like, just make a guide or a tutorial or a piece of content of any sort that you will like to read. Yeah, that would be my general idea. But yeah, not on a specific topic, just something that you feel that will help and other developers will appreciate. Something that's new, something that, yeah, very custom to something with that you will enjoy yourself.
How long did it take to build this scroll demo, right? Because we're dealing with relayers, we're dealing with
Mm.
the zero knowledge, like this specific demo right here. I mean, is it feasible to do in a week, or did it take a couple weeks to make that happen?
Yeah, if it's the first time, I think a couple of weeks. Yeah.
Yeah. Okay. Yeah.
Yeah. But yeah, at this point, if you are very familiar with it, it will flow easier. But the most important part at this point, I think it's what you can actually do. And I'm going to talk about some, just to close up after we finish with this demo. I'm going to talk about some caveats and some stuff that are not yet resolved, because is CK production ready? I think if you can wait for the minute here and a half, yeah, that will count as a yes. And of course, with the new improvements, that will improve by a lot. But also there are some caveats here, and also I think it will be worth writing about those if you're participating on the contest. So yeah, just let's just look at what happened here. So I signed, it generated the proof. Here is the proof, and then it was relayed. Here's a message that it was relayed to my backend here. So my backend received the transaction and posted it on chain on scroll. So now I'm going to go to Etherscan, scroll scan in Sepolia, and we're going to see the transaction on chain, that basically this transaction was signed from my MetaMask account, was passed to the relayer, and the relay signed it on chain. So here it is confirmed. So if I refresh here, I will be able to see the new comment here. Yeah, so now there are two comments, and yeah, it's the way it works. So let's just go and see how is this possible, and how is it different from our simple example. So here we are also using Noir, the same, but of course we are using a lot more of code, because now we're passing our signature or public
Can
key.
can you make that just a little bit bigger for everybody on the screen? I don't think I'm not sure if we can follow along on that. Yeah, that perfect.
Okay. So we're passing our public keys and our signature, and also this makes it a little bit complex, but yeah, it is also important that we pass a Merkle tree. So instead of storing all the members that can post in this port, instead of storing in a mapping or an array, we store it in a Merkle root, because in a Merkle tree, because Merkle trees are, you can post lists in Merkle tree that are very CK friendly and Solidity friendly both. So yeah, just to save gas and proving time, we use a Merkle tree. But the idea of a Merkle tree is simple. It's just a list. So we pass. Okay. So the question here in the circuit is this user that hashed this message, is it part of this Merkle tree? That's the question that we ask here. So first, we validate if the signature is valid and the user is correct. If the signature is correct, so we don't trick the circuit to generate an invalid proof, then we check if the user is part of the Merkle tree. In other words, we check if the user is part of the list, yes or no. And all the assertion has to be satisfied, all the assertion has to be true in order to generate the proof. So the proof is generated on the front end. So we have here a web app, and so you can take a look at the code. So the same commands that we did are going to be called from here, but from Solidity. So here in Solidity, we're going to have a function that is called generate proof. And then the proof, yeah, just pass the inputs. We pass all the inputs from the circuit here, but now from your JavaScript library, from I don't know, Vue.js, Angular, React. You generate all the parameters, you pass it on the JavaScript library, and that will generate the proof on your browser to protect your anonymity and protect your private inputs. And then at this point, you can send all the proof and everything direct to the smart contract. But yeah, as we mentioned, we don't want that usually. We will pass it to a relayer to keep our transaction or our anonymity safe. Just to mention that not all CK apps are anonymizing the user. Some are anonymizing other stuff. So it doesn't matter if the user himself submitted some. In some apps, you want the relayer, but here, just to have like a more complete example, I also did the relayer thing. So here I just call the relayer, which the relayer is actually in this case is very naive, and the relayer is just like a normal just Express.js, very simple API that just receives any transaction, just receive a transaction and just relays it, just receives and relays, just send it on chain. And of course, you don't want this in a public environment because you just run out of gas like super quickly. And yeah, you don't want it. So you need to find ways of incentivizing it. Yeah.
But you're basically filling up the relayer with your own gas, and then you're just sending it for testing purposes. Yeah. So you have to fill the relayer with your own gas, or somebody has to fund it, and then it's paying for that transaction. Yeah.
Yeah, exactly. Yeah. And usually that logic should be, for security reasons, should be on the contract. Yeah. The contract should be able to pay the relayer something. And yeah, so here is my contract. This is my custom logic contract. Oh, here I have some like I had to have some to string conversion and from hex to string, just to have to do some very just some work there. But this is the custom logic that we are interested about. So as you remember, as we usually do, we have the same functions that receive the proofs and the public inputs. And we also receive the comment in a string. So the important part here is that we have to check if everything is valid. We have to check if we pass the correct message. We have to check if we are talking about the same Merkle tree, because in the circuit, we can prove ownership of any Merkle tree, but we store on-chain the Merkle tree, which means the list that we're talking about, the one that we want to work with. So we verify everything. We verify the message, we verify the Merkle root, we verify the proof itself, and then comes the custom logic. And here the custom logic is just storing my comment in a sequential mapping. And that's my comment here. You can imagine what other stuff you can do, like voting, like DeFi, NFT, yeah, whatever. That's the thing that can be done here. But yeah, this is just the core of the example. Yeah.
Yeah. I like it. You're really good, especially for those like that haven't messed around with Merkle trees yet. Don't get caught up on it. It took me a little while to figure out, the Merkle tree.js and then understanding like the roots. There's a good YouTube video out there that just all of a sudden when I watched it, it clicked. And I was like, oh, okay, it's just part of a leaf, and part of that, and how I can verify it based on your wallet address. That's how a lot of the NFT like allow lists were making it, because if you put a whole list of like 200 wallets in an array, obviously way too much gas when you mint. So everybody started switching over to Merkle trees, and so it's just one of those really good libraries to learn overall. It's one of those
Yeah,
things
yeah,
that you learn
yeah.
takes care of you. Yeah.
Yeah, I think it's fun to learn about it. It's a good primitive in blockchain. Also, it can help you understand other stuff like how Ethereum or Bitcoin works in general. I think it's very,
Mm-hmm.
very, very interesting. Yeah. Yeah. So just to doing some recap about the general architecture of your CK dApp. What does it need to have? So you will need a circuit. In this case, we use Noir, but you can replace it with Circom or Socrates or even H2, which is the one that Scroll uses for building Scroll. And you will also need a solidity verifier that is going to be generated for you. Then you can combine it with a custom logic from yourself. Also, in this case, we use Node.js as a layer, but you can use like a Django application on Python or a Ruby on Rails or whatever backend that relates to transaction. But you also need to figure out a way of incentivizing him. And finally, we need Wasm program. Wasm is the running assembly code from your browser just to optimize it. So you will need to run stuff on your front end. In this case, we use Vite.js, but you can use whatever JavaScript framework that you're using on the front end. So that's the general architecture of your CK app. That's all the knowledge that you need to have. Some are optional, like the relayer. You can do CK apps without a relayer if you're not anonymizing the user. So yeah, that's what you usually need to know. And also some important things that I want you to know, but just again on the end of this, is that also, yeah, so a couple of interesting things. Also, maybe you can grab ideas to write stuff from here. So something that we actually mentioned before, there was a really good question about it before. What about hashing functions? Yeah, just remember that Keshak is not CK friendly. Keshak is very, very CK unfriendly, but it's the one that uses Ethereum. So we usually need to have it. And also Pedersen and Poseidon are other hashing functions that they too are CK friendly. So when possible, use them. So in our example, we use Ketchak to check your user, to check your signature. We use Ketchak for that because that's what Ethereum does. Or the MetaMask pops up and we're doing a Ketchak thing there. So we need to check that on the circuit. And then we use Pedersen, but we could also have used Poseidon to make the nullifier. That it would be like, because it's faster. Other important thing is that to mention is that Scroll is very proud to be the only it's the most compatible it's the most CK compatible CK EVM, and so on Scroll you can deploy Aztec like Noir and Noir circuits like we did now. You can also deploy Circom. You can also deploy Socrates and verifiers, and it works on Scroll. But it doesn't work on all CK EVM chains because the CK EVM chains need to support the specific opcodes and precompiles that are needed from the DSL that you're using. So you before you deploy on a specific chain, just make sure that it's compatible. But yeah, happy to announce that Scroll is compatible with all the major DSLs. And other thing that is very important, that what we did today, the demo that I bring you with the um, MetaMask signing, it's not compatible with. There's no way of nullifying that, which means that, for example, we have our comment, but you can't moderate. You can do stuff like, okay, you can submit a transaction only once per day. Some stuff you will let a nullifier for that. And the thing is that on the way that we just did it, you can't nullify. There's no way of doing that, and this is a big problem. For example, if you want to build a voting app, for example, you won't be able to nullify your vote, so you can vote endlessly. So you don't want that, obviously. So there are some alternatives for this. And if you actually, this is a good. I may not say too much about it because I think this is a good topic for research. Maybe you can look for stuff like Plume to make signatures nullify friendly, but they also have some caveats. They need to grab more support. And yeah, but yeah, this is just things to know that there are some stuff that the last pieces from CK are just getting together just to bring like users like a good experience. Yeah, this is the workshop that I prepared for you guys. And yeah, I don't know if there are any more questions, but in general, I want to invite you to keep an eye on what's going on in the CK world. I think at this point in time there's a good opportunity for us developers to get to know this and to disseminate the information about what is possible on CK. One, because I think it's very fun and there's a lot of new stuff, but also because I think good, really important use cases can arise from here. I think privacy is a very important thing. And also, of course, privacy doesn't mean doing like non-compliant, non-regulatory compliant stuff. Of course not, because this tool is, I think CK is so powerful that can help us bring these new capabilities in a way that is also compliant with the law. So yeah, I think it's super important here what's happening on CK. So yeah, there is a lot of reasons and a lot of fun that you can have building stuff, and of course sharing the knowledge. That's why at Scroll we feel like yeah, we're very excited to see what you guys write on, and yeah, we'll be reviewing what you write.
Awesome. For those that were a little bit late to the workshop or missed the QR code, I'm going to paste that link one more time on there. And we'll update it on the Notion doc as well as a resource. That way you can refer to it. And then just a reminder, this Thursday at 12 a.m. UTC. I don't want to say Thursday because Thursday and Friday can like blend depending on what time zone you are. So yeah, the fun with the workshop. But 12 UTC. That's going to be the cutoff time for submissions. Definitely check it out. Submit what you got at that point. There's a lot of opportunities to learn so many different subjects on here. I know we have 3 categories. It's going to be the Applied ZK, which we just kind of like went through a really awesome tutorial. It's probably one of the best ones that I did to like actually like click and make sense in my head. Like, oh, this is how it works. With a cool example. We also have DIDs on Scroll, like with Spruce ID, Disco, Lit, Protocol. Those have its own separate category. And then we also have gaming on Scroll, which uses MUD or Paima. And I think Paima threw in another 2 $100 prizes for those that do articles on that with on Scroll. And then we do have an overall prize pool just for even trying. Something that has a little bit of effort into it is part of a prize pool of $1,000 as well, a total of $7,200. So if you're not writing anything on Scroll, I don't know why, but we have until Thursday. There's the Telegram support. There's potential gig opportunities at Scroll that are going to be coming up. So put in your best foot forward and let everybody know what you got. And I think this was an awesome workshop. Like I was there starstruck with my mouth open, like, oh, okay, it's making sense now. Because this is zero knowledge is hot. Like if you're on Twitter or your socials, it's got to be half your timeline. Everybody's talking about zero knowledge.
Yeah.
It's like always there. You can't get away from it. Yeah. So I much appreciate it, Ahmed. Again, are you handling on the Telegram? I know Raza is too. Are you handling zero knowledge questions there?
Yeah. Rosa and myself will be handling on the question. If you have any questions or share anything, yeah, nice to see you on the Telegram. Also, thank you for your great questions. And yeah, good to see interest in anything secret related. It was really really good answer. And thanks to you, Billy. I think you have been a super great host, great energy, a great pace. Yeah, really really like it.
Thank you, thank you, thank you. Yeah, hope to have you back. I mean, as we get more breaking changes and more stuff, more things that come in there, we'll see what
Yeah.
else your knowledge has for us on there. But on that note, guys, we're gonna go off stream. Good luck on the. I'm gonna get this right one day as soon as it ends. The Quill and Scribes workshop. I just think of Scribes. All right, guys, have a good one.